In this video, I will show you an example using numbers of how to use Biot-Savart's law to find the magnetic field from a single charge. Now, I kept the same picture as the video where I went over the theory and the steps. Here are the numbers. So this information is given from the problem. The position of the source charge, so where the moving charge is 1, 3, 0. Sits on x equals 1, y equals 3, and the z is 0. The charge is on the xy plane, and these are in meters. The observation location where I want to find the magnetic field, that is at a position of 4, 4, 0, okay, meters. Again, this information is given from the problem. Now, the next thing that I need to do, I need to find the vector that goes from 1 to 2. And that is the vector r2 minus r1. In other words, r obs minus r source. So I'm going to write those two vectors here. And as usual, when I subtract vectors, I will subtract each component separately. So I will do 4 minus 1, and then 4 minus 3, and then 0 minus 0. And this will give me 3 and 1 and 0. Now the next step, by the way, I can show you here. What I just found is this vector. The vector that goes from 1 to 2. This is the vector that goes from 1 to 2. Now the next step is to find the magnitude of this vector. And to do that, I need to use the square root of x squared plus y squared plus z squared, and in this case it will be the square root of 3 squared plus 1 squared plus 0 squared. So this will give me the square root of 10. And I will leave it like that. If you want, feel free to convert that to get rid of the square root. Alright, so the next step is to find the unit vector. And to do that, I need to take the vector r from 1 to 2 and divide it with the magnitude. So I will have, I'm just copying numbers. And I'm dividing this with square root of 10. Now take a look here. This vector had units of meters. The magnitude had units of meters. When you take the ratio, the units cancel out. So the unit vector has no units. Now the result here will be 3.0 divided by the square root of 10, comma 1.0 divided by the square root of 10, comma 0. And as I said, there are no units for this. Now the next step will be to, well, just to make my life easier, I think at this point I will go ahead and write the vector r from 1 to 2 Alright, now I have this is just the unit vector. I made a typo. So now that I have this vector, the next step is to find the cross product. Now, here, the velocity of the moving charge needs to be given from the problem. So let's make a note here, okay, that this is given from the problem. Let's make it for, since it's in the positive x direction, let's make it for 0 meters per second. Now, to help you understand a little bit better how we're gonna do this, I'm gonna do the following. I will start writing what is the cross product for two generic vectors A and B, and then I'm going to apply that for the cross product that I want to calculate. Okay, and I'm gonna do it component by component. So I have V1 cross R hat all right. Now the vector A is the vector V, and the vector B corresponds to the R hat vector. So when I see A sub y, the y component of A, that means I need to use the y component of the velocity. Okay, let's take a look. The y component of the velocity is 0. If this is 0, no matter what this is, I'm gonna get the 0 for the product. Now AZ, the z component of A is the velocity. The z component of velocity is 0. Again, no matter what this is, the product will be 0 again. So there we go. That was the x component. Now for the b component, I have AZ bx minus ax bz. Let's see what that will give us. So A is the velocity vector, corresponds to the velocity vector, so this is the z component, and I already checked that before. The z component of A is 0, so this product will give me 0, minus Ax, this is the x component of A, which is the x component of V. Oh, this one is not 0 this time, so actually I do have a number that is not 0, Ax times Bz. Now this is the z component of the vector B. That means I need to use the z component of the vector R hat. But the z component of the vector R hat is 0. So that product is 0 as well. And the last one will be Ax by minus Ay bx. Let's take a look. The x component of A means I need to use the x component of V, so that is the 4 times the y component of B, and B corresponds to R hat. I do have a number that is not 0, so that will be the 0.32 minus the y component of A, and the y component of A corresponds to the y component of the velocity, which is 0. So whatever this is, whatever bx is, it doesn't really matter. It's going to give me 0. So the cross product is 0, 0, and 4 times 0.32. So this is what the cross product is between the two vectors. Now that I have this vector, the next step is to plug in everything and find the final result. The constant mu naught over 4 pi is 10 to minus 7. And then I need to use the charge Q1. This needs to be given from the problem. Let's say that this is a proton. So I have a 1.6 times 10 to minus 19 coulombs. So the constant times Q1, and then I have times the cross product, 0, 0, 1.3, and then I need to divide this with the magnitude squared. The magnitude was the square root of 10. If I square the square root of 10, I will get simply 10. So this will give me, now in general, what I recommend here, I recommend that you do these calculations separately. You find the number for this, and whatever number you get, simply multiply every component of that. So now 1.6 divided by 10 will give me 0.16, and 10 to minus 7, 10 to minus 19 will give me 10 to minus 26. And then this will be times this vector. Now, fortunately, only one of the three components is not 0, so that does make my life significantly easier. The only number that I need to calculate is 0.16 times 1.3. Tesla. And this is the magnetic field that this single proton is creating at the observation location. Okay, so this is the process that you need to use to find the magnetic field from a single moving charge. As I said before, probably the most challenging step is to find the cross product. What I recommend that you do, write down this expression for the cross product, and then carefully, one component, one number at a time, find out what they are and plug them in here, and again do the calculations as carefully as possible.